Download this code from codegive.com, link in the description below. Inverse kinematics, IK, is a crucial aspect of robotics, particularly for robots like quadrupeds that require precise control of their limbs to navigate and interact with their environment. In this tutorial, we will discuss the principles of solving inverse kinematics for a four-legged robot and provide a code example. Overview of inverse kinematics. Inverse kinematics involves calculating the joint angles needed for a robot's end effector, like a foot, to reach a desired position in space. The problem can be complex, especially for multi-joint systems like a quadruped robot, which typically has multiple degrees of freedom for each leg. Structure of a quadruped robot. A typical quadruped robot may have 4 legs. Each leg could have 3 joints: shoulder, knee, and ankle. Joint definitions. One shoulder joint, θ1, controls the movement of the leg forward and backward. 2 knee joint, θ2, controls the bending of the leg. 3 ankle joint, θ3, adjusts the foot orientation. Forward kinematics. Before we dive into inverse kinematics, let's understand forward kinematics briefly. Forward kinematics calculates the position of the end effector, foot, based on the joint angles. This will help us understand how to reverse the process for IK. Inverse kinematics. To solve the inverse kinematics problem, we need to determine the joint angles for the desired position of the foot. This can be done using geometric methods or numerical methods. For simplicity, we will explore a geometric approach. Steps to solve inverse kinematics for a quadruped robot. 1. Define the desired position, specify the desired x, y, z coordinates for the robot's foot. 2. Calculate the lengths, determine the lengths of the robot's leg segments, L1, L2, L3. 3. Compute joint angles. Calculate θ1 using trigonometry to find the angle at the shoulder. Calculate θ2 for the knee joint using the law of cosines. Calculate θ3 based on the orientation needed for the foot. Code example. Below is a simplified Python example that demonstrates how to compute the inverse kinematics for a single leg of a quadruped robot. Explanation of the code. 1. Leg lengths. We define the lengths of the leg segments. 2. Function definition. The inverse underscore kinematics function takes the desired x, y, z position of the foot. 3. Calculating angles. θ1 is computed using the aten2 function to determine the orientation of the leg in the horizontal plane. The distance d to the desired position is calculated, and we check if it is within reach. θ2 is calculated using the law of cosines. θ3 is derived based on the geometry of the leg. For error handling, the code handles cases where the target position is unreachable. Conclusion. This tutorial provides a basic understanding of inverse kinematics for a quadruped robot. While the example is simplified, real-world applications may involve more complex models and considerations, example avoiding obstacles, dynamic movements. For more advanced implementations, libraries like KDL, Kinematics and Dynamics Library, or PyBullet can be used to simulate and analyze kinematic chains in robotics. Feel free to experiment with the code and adapt it to your specific robot configuration.